Hello, my name is Nicole Grillo, and my presentation is on emerging technology. It's going to be on quantum technology. I'm really excited to share what I have learned with all of you. So in order to understand the basis behind quantum technology, it is essential to understand the basics of quantum physics. Essentially, quantum physics explains how atoms do not follow traditional rules of physics. Quantum particles can move either forwards or backwards in time, exist in two places at once, and teleport by a process called quantum tunneling. Quantum technology utilizes this theory of physics to produce technology that will change the world. I have always loved to challenge myself and to learn new things that are difficult for me. I have never really been great with chemistry and especially with physics, so understanding quantum physics was going to be a task, but one that I was excited to partake in. Quantum computing and quantum technologies are the future. It is clear they are going to be upon us sooner than most anticipate. I think it is thrilling to look at a concept so broad and incredible in nature and apply it to information technologies and the future of its engineering. We can thank the physicist Max Planck for his study on the effect of radiation on black body substances for the birth of quantum physics. His experiments proved that energy can display different behaviors in situations which he labeled quantum. The birth of this idea was dated in 1918. Other scientists such as Albert Einstein furthered this theory, creating the basis for quantum mechanics in the 1920s through 1950s. In 1994, Peter Shor's theory was released, which created a quantum algorithm for creating large numbers far faster than most conventional computers. Fast forward to within the past 2 decades, where quantum technologies have made incredible progress, from various Nobel Peace Prizes on research in quantum physics to applied investigations. So this right here would be a slide about quantum technologies. So classic computers work on a binary scale, so they always are in two different states, either 1 or 0. Quantum computer work with qubits, which can either have 3 states, 0, 1, or both 0 and 1 at the same time. So the state of being both 0 and 1 at the same time is called superpositioning. And basically, instead of analyzing a 0 or 1 sequentially, a superposition allows 2 qubits in a superposition to look at all 4 scenarios at the same time. Thus, this eliminates the amount of time it takes to look at a particular data set. The downside is that qubits are extremely fragile, and their ability to stay in a superposition can be jeopardized by radiation, light, sound, vibrations, heat, magnetic fields, and etc. This is called decoherence. And decoherence is when a quantum system reverts back to its classical one due to an interaction with the environment that decayed its superposition. Key ideas to take from this: quantum technologies use superpositioning to decrease the amount of time it takes to compute a data set. Decoherence is the decay of this superposition. So before I get more into quantum technologies, I also want to discuss some theories that were really important for quantum technologies and quantum computing and quantum physics in general. So the first one I wanted to discuss was Peter Shor's algorithm, which is a quantum algorithm designed for quantum computers that calculates prime factors of a large number. This algorithm became ultimate race for quantum supremacy. This equation makes large-scale and difficult algorithms possible for quantum computers. So coherence length is the time a qubit can survive in its quantum properties or in its superposition. And it's important to understand coherence length, as this is one of the main problems individuals are now currently working on. The longest amount currently that a quantum property maintained was a superposition of 39 minutes. In order to use these products on a daily basis, they should be drastically improved. Quantum error correction was a theory based upon conventional error code correction, where information is copied then encoded in multiple bits. This helps with the idea of decoherence and then coherence length. And then Peter Shor's quantum error correction code, and this is the use of entanglement, which helps discover and fix faults while keeping the state of the qubit intact. And this deals with the theory of quantum error correction and how individuals will use this idea of entanglement to create a better coherence length. So, as I mentioned earlier, Peter Shor's theory, quantum theory, essentially created this race for quantum supremacy. And quantum supremacy is the potential ability of quantum technology, especially computing, to solve problems classical computers and devices cannot. Essentially, it's important because the organization that holds the key for this technology will be able to create a new technological future. Quantum supremacy will initiate an influx of technologies that will create new pharmaceuticals, a huge change in cryptography, and ultimately the way that society now tackles the problem and finds a solution. So, China has a satellite in orbit that is capable of quantum communication with the ground, and Google is currently testing and building a supercomputer that will use quantum technology. IBM has created a 16-qubit computer that can become fully entangled. Quantum entanglement is a quantum mechanical phenomenon in which the quantum states of two or more objects have to be described with reference to each other, even though the individual objects may be spatially separated. So essentially, IBM has created this computer that is able to go through a quantum entanglement, which, if you remember from the theories, entanglement is essential in order to help with decoherence or preventing decoherence. Microsoft has released a quantum development kit, which is very interesting. It's actually available on the market to anyone who wants to try it. And they allow individuals to test their skills with creating programs from quantum technologies and computers. D-Wave is a Canadian company that currently has one of the first functioning quantum computers, and Harvard's University Mikhail Lukin has created a 51-qubit quantum simulator. So, the uses of quantum technology, quantum simulation. So, quantum simulation deals mostly with the change of finance in the way that individual simulate investments, and it will be able to simulate complex quantum systems to give a better projected outlook to investors and change the way individuals will speculate. This will be huge in stock markets, individuals, and how they create hedge funds and mutual funds, and etc. So, the uses of quantum technology, quantum communication, and this essentially quantum communication will offer the ability to send data from one area to another with total confidentiality due to the law of physics. Essentially, this will be a safeguard for technologies like quantum computing and its ability to break most common encryptions. It will revolutionize and maintain the privacy of business and government and military communications. Additionally, this will help create enduring and dependable cloud storage as well as cryptography-related tasks. So the uses of quantum technology, quantum computing. So speculative computational structures that are use quantum mechanical events like superposition and entanglement to execute functions on data. They use quantum bits, qubits, to superposition states. They will soon be able to break encryption typically used today. They utilize quantum means to generate unheard of data processing performance. Quantum algorithms can radically best classical computer computations and completely changes the way individuals will engage in cryptanalysis. So essentially, quantum computing is going to be huge. It's what quantum supremacy is basically all about. Anyone that really engages in creating a quantum computer wants this technology in order to create a better use of the computer technology. Right here is a picture of quantum technology on a circuit board, or what they believe it will look like on a circuit board once they have created a technology that will be able to use it to its fullest extent. So another use of quantum technology is quantum sensing and meteorology. and that is quantum sensing will allow us to measure the universe at a scale of atoms and photons over suitably short time scales. And quantum sensing will allow the creation of quantum clocks, which will be more precise and additionally allow more sensitive and capable optomechanical sensors. So there's many benefits and effects on society. The first is safer airplanes due to software tests that are currently too complex for classical computers. The discovery of distant space as quantum computers will be able to analyze the large amount of data collected from telescopes. The change of marketing of politics because individuals will be able to delve through multitudes of marketing information to best find voter preferences. Quantum computing will help design software that will help cars distinguish landmarks and ultimately drive themselves. Quantum technology and computers will revolutionize meteorology and weather forecasting and create more precise forecasts. It will also allow for more sophisticated analysis of traffic patterns and routes to help with bottlenecks in heavy travel. And continued on, a really great example I read was an MRI example. So we can use quantum technology like an atomic magnetometer in order to turn a very expensive and extensive process that an MRI is at the time into a small and affordable component that could be available in every doctor's office, which means that individuals that may have something that they don't want to get checked out because an MRI is expensive and extensive, they'll be able to really get fixed as they just go to their regular doctor, which is huge for individuals, and it also will be huge for people that need a small checkup, but they're unsure of something, and it ends up becoming a bigger issue. Quantum technologies will also transform mapping of cells, amino acids, and will help doctors and researchers discover better treatments and drugs to help with various issues. Quantum computing will help shape better computational models to help understand the development of disease and ultimately how to cure them. Huge factors can be computed instantly, which will be a huge development for code breaking and internet security as well. So with every effect on society, there's also going to be some drawbacks. Currently, encryption will become completely worthless due to properties of quantum technologies. There's going to be a loss of various jobs due to increased confidence in technologies, which, again, due to the benefits, there will also be an increase in different jobs due to the new technologies and what they'll need. However, various jobs like meteorologists and etc. will probably become non-existent due to the various probability and data set patterns that quantum computers can solve. The necessity to understand the properties of quantum physics and the various theories that are used to create quantum technologies are not really easy to grasp and apply without proper education. And in order to really understand these technologies, it does take a good amount of education and the ability to properly put them together and utilize them. So that will definitely be just a drawback in the way that it's going to be difficult to find individuals that really grasp this technology and understand how to use it. Additionally, the rapid change from classical processes into progression involving quantum technologies such as meteorology and simulation. Quantum computers and their respective qubits tend to run much hotter than classical computers and need an environment to stabilize it in order to keep its superposition. The required temperature of these products is near absolute zero, and the D wave 2 is kept at negative 459.6 degrees Fahrenheit. As you remember, the D wave company is the Canadian company that created the first quantum computer. So their D-Wave 2 is that quantum computer, which is kept at a significantly cold temperature. Quantum technologies will need entirely new configured software that are created to best fit their respective systems. Quantum technologies will additionally need a QUI or a quantum user interface, so they are more user-friendly for individuals trying to work with these various products. There's many pros of this emerging technology. Some of them are quantum technology will transform modern technology and make things that were once impossible possible. They will fundamentally change the way computers are encrypted and cryptanalysis. Quantum cryptography will create a much more secure and reliable Internet of Things. Quantum communication will create more secure and superior connections with individual and government entities. Quantum simulation will revolutionize the process of finance and investments through various new algorithms. And additionally, quantum sensing and meteorology will create a more accurate and precise weather tool. Some cons of emerging technology is the loss of various jobs due to confidence in the new technology. Modern encryption and cryptography will become useless against the power of quantum computing. Hopefully, quantum communication, however, will solve this issue. At the moment, it would be difficult to make this technology accessible to the general public due to the environments they currently need. The ability of what this technology can do in the wrong hands is pretty large. Obviously, if an individual were to process this technology before, if, for example, a government entity, they would be able to essentially hack anything they wanted to and get any type of information, which is a pretty substantial problem. Additionally, the current cost to produce this technology is a huge expenditure for most companies and governments, which I will actually show you on the next slide. And so this is the cost of quantum technologies at the moment. This is from research done in 2015. All the numbers you see here are in millions of euros. So the euro right now, I also believe, is about 1.4 to 1.5 or 1.2 of what a dollar is. So you have to multiply it by that amount and then multiply it by a million. So for example, just in the United States alone, it's 360 million euros. And a world estimate is 1.5 billion euros. So it's a pretty expensive technology to really understand and focus on. So the impact on job force. So meteorologists, taxi drivers, and etc. will become unnecessary due to the precision of quantum technologies. There will be updated versions of Google Maps, Waze, and etc., which will actually help with heavy traffic zones and create a better work commute. Education and training quantum technology and in the quantum technological field of choice will have to become an obligation for an individual that wants to work in it. And ultimately, schools will have to incorporate new programs on these technologies and help with on-the-job training for them. Most individuals that start, or most companies that have started creating quantum technologies actually bring in the engineering departments of the groups that they're working with in order for them to understand the process of what they're doing to create the technology, so the engineers that are going to buy this technology for their company are able to better grasp how to use it. And ultimately, schools will have to incorporate new programs on these technologies. Individuals in the information technology fields will have to change the way they think about how these computers and technology work. So because it's not working binary anymore, it's working qubit, it's going to be a completely different way of thinking. And overall, it will impact the amount of jobs out there due to an emphasis on analysis, precision, and efficiency. It will become required for individuals to increase their knowledge of quantum physics and let go of more classical trains of thought. However, it will have a huge impact on the field in the way that these technologies will increase the jobs that to create these environments, to work in the companies that will create these products and then sell these products. Ultimately, this technology will completely reintroduce a new field into the job force, and I think ultimately will create a large amount of jobs. In conclusion, quantum supremacy is almost upon us. There's multiple companies that are in the race to come up with products that will change the way individuals use this technology forever. Quantum mechanics, computing, and physics will all play a key role in the way we handle problems in the future. It is essential to understand the fundamentals of quantum technologies in order to best grasp how much society will be affected and ultimately with all of its pros and cons. Thank you. Next is the references slides. So this is all the information that I used in order to create this program. Thank you. Take a further look, it goes over 4 of the different technologies that I'll actually be discussing in future slides. It's really interesting because it actually goes into the future as well, so like what they're planning on having for quantum technologies, which I think is going to be very interesting.